Assalamualaikum viewers, today we'll start with the packet switching and circuit switching. We will find the differences between both of them and their formal definitions. So the network core, mesh of interconnected routers. The network core is mesh of interconnected routers. These all are routers. These are interconnected. So the fundamental question: how is data transferred through network? How is data transfer between these networks? So, circuit switching. The resources needed along a path to provide for communication between the end systems are reserved for the duration of communication session. And here comes packet switching. The resources are not reserved. A session messages use the resources on demand and may have to wait in queue for the access of communication links. So, circuit switching. End-to-end resources reserved for call. A bona fide connection for which the switches on the path between the sender and receiver maintain connection state for that connection. This connection is called circuit. Circuit maintain constant transmission rate in the network links for the duration of the connection. Each of the link in circuit switching has n circuits, so each link can support n simultaneous connections. Switch capacity and dedicated resources, no sharing. These are dedicated resources for their connection. Guaranteed performance, circuit like call setup required. Call must be set up for this connection. You can see in this video, the right side on the slide. This is the circuit switching example, in which the two hosts are interconnected by different circuits. A dedicated end-to-end connection between two hosts. The circuit in a link is implemented with either frequency division multiplexing or time division multiplexing. So what is FDM and TDM? So FDM, the frequency spectrum of a link is divided up among the connections established across the link. The frequency band in telephone network has a width of 4 kHz. In frequency division multiplexing, the frequency is divided into different bands. And TDM means time is divided. So in TDM link, the time is divided into frames of fixed duration, and each frame is divided into fixed number of time slots. When network establishes a connection across a link, the network dedicates one time slot in every frame to this connection. This is example of FDM, which is the whole frequency spectrum and time is given to one connection. For example, we have 4 users. Blue is one user, green is other, yellow is other, and pink is other. So the frequency is given. The frequency is divided into different users, and they are given at one time. They are using the same different frequencies by in the same line. This is example of TDM, where frequency is divided as per time, and different time slots are given to the users. So what is packet switching? In packet switching, the packet is sent into the network without reserving any bandwidth. In this packet switching, we do not reserve any bandwidth. Each end-to-end data stream divided into packets. User A, B packets share network resources. Each packet uses full link bandwidth. Resources used as needed. So resources contention. Aggregate resource demand can exceed amount available. Congestions. Packets queue wait for link use. We will see about congestion and aggregate resources in the next videos. Store and forward. Packets move one hop at a time. Node receives complete packet before forwarding. This is the example of packet switching. Statistical multiplexing. This is the router view of packet waiting for output link. When host A and host B send some data, it will wait here. This is the statistical multiplexing, and C, D are the receivers. So sequence of A and B packets does not have fixed pattern. Bandwidth shared on demand. First come and first serve terminology will be used here. TDM, each host gets same slot in resolving TDM frame. Store and forward takes L by R seconds to transmit packets of L bits onto the link at rate of RBPS. Store and forward, entire packet must arrive at router before it can be transmitted on next link. So how can we find delay? Delay formula is 3L by R, assuming 0 propagate delay. For example, L is equal to 7.5 megabits and R is equal to 1.5 megabits per second. Transmission delay is equal to 15 seconds. How do packets make their way through packet switch network? How a router takes a packet arriving on one of its attached communication links and forward that packet onto another of its attached communication links. Each packet traversing the network contains the address of the packet's destination in its header. At the arrival of the packet, the router examines the destination address and forwards the packet to an adjacent router. Each router has a forwarding routing table that maps destination address to outbound links. Forwarding routing table is created, updated automatically by the routing algorithm protocol. We will see these topics in detail in the next videos. Thank you very much. Please subscribe our channel for further videos.